Now we're live, I guess. This is my first time on camera, first time doing anything like this. You've got some experience today. You actually probably are exhausted.
Yep.
Yeah.
It's tiring. It looks easy, but
Yeah.
apparently it takes a lot longer to do the simple things than you'd guess.
Yeah. We were exhausted just sitting in the audience and processing everything that you were giving us. So
Good.
We're gonna give you a little break from science to start this thing. And it was Courage in some behind the scenes footage. He asked me a question about what it's like having you as a dad. And I think that the answer really is the way that you approach physics and the way that you question everything that's going on in physics is basically the way that you approach everything else in your life, right? From a very young age, he was skeptical of sunblock. Anything above 8 SPF, you basically thought did more harm to your skin than good. And what's funny is people thought you were crazy for that.
I get a chance to defend myself, right?
You do. And actually where I'm kind of going with this is there's studies that are coming out that are kind of confirming your belief there.
Yeah, I did some research in it. I couldn't understand how you could rub some lotion on your skin and your sun would not come through. There's some type of chemical reaction that has to take place. Mm-hmm. And I did some research on skin cancer and dermatologists. And it turns out that before 1960, there was virtually no skin cancer. Mm-hmm. And my parents were out in the sun all the time. They lived here in Southern California. And people were not getting skin cancer. And there were no dermatologists. In the 1960s, sunblock came out that chemically altered something. And then skin cancer went like this. Now, those might be two completely unrelated issues, but I just I don't blindly trust things.
Yeah.
Question.
Not surprisingly, that led to you avoiding the vaccine when it came out.
I didn't take the vaccine. I was vaccinated by God. I got the COVID the first month it was out because you brought it back from New York.
Yeah. All right, Aaron Rodgers. Okay.
No, I didn't get it. There's no way in 1 year they can rush a vaccine out that's better than the actual disease itself.
Yeah, fair enough.
So my immune system's going to react. It's going to react.
Fair enough. So my question is for you, what do you think led you to look at the world in this way? Was it something you were naturally born with, or was there something about your upbringing that?
I think it's a function of being dyslexic. I learned in high school that I was severely dyslexic, and I think it forces you to survive, particularly in school. You've got to think about things differently. I couldn't read textbooks. You got to figure out a way to get the information without. And so I look at things differently. I treat them all as complex problems to solve. And when I was introduced to physics, I didn't really care that much about it. But man, it didn't make any sense at all. It was a bunch of gobbledygook. So as time went on and things happened to me, I confirmed that.
One last question about your upbringing. Your dad very much trusted the experts, right? He would walk into a doctor's office and they had a PhD, so they knew what was right. He had no idea, and he wouldn't question or challenge them.
Yep.
Your mom, I never had a chance to meet.
Yeah.
Was she more like you are?
Yes.
Or was she?
Yeah, she was far more open to challenging norms, challenging convention. Probably not to my extent for different reasons, but yeah, she was far more open to not blindly following the experts.
Yeah. So that really is the root of all of this in a way.
That I think is one of the things that really helped me get to the point where I've gotten to. Yes. Yeah.
Makes sense. So here's a little intro. I'm not sure how this is going to fit in or how this will be edited, but most dads think that they know everything, and I think you kind of take that to the next level. And the heart of why we're here today and what we're doing is that you have a new theory that you think should replace Einstein's theory of general relativity. And we've spent a lot of time talking about that theory today from start to finish, but I think it's important to discuss why we actually need a new theory. You've done a lot of talking today, so I'm going to kind of explain this in my words here quickly. But the fact of the matter is, the current theory is flawed. And scientists don't want you to know this because they're posting these articles and they want you to think that they're experts. But if you ask them the right questions and if you dig into their websites, they will say that the current theory is flawed. The CERN website actually says explicitly, the standard model is flawed, it leaves many open questions. But instead of going back and rethinking that original theory, what they are doing is spending billions of dollars test working patchwork theory. Basically what patchwork theory is, it's a combination of flawed theory and observations that contradict that theory. They assume the original theory is correct. So when they when they're confronted with contradicting data, they draw conclusions through default logic. Over time, these stack up and they become so overly complicated that they make little to no sense. So the idea really is you have this flawed theory, you have contradicting observations, and instead of going back and reevaluating that flawed theory, you make these wild, outrageous patchwork theories on top of it.
Yeah. Been doing that for 50 years.
Been doing that for 50 years.
Yeah, it's a function of the industry. It's, they all know it's screwed up. They don't want to be in it when the revolution hits, when the paradigm changes.
Yeah.
They have kids in college. They got mortgages they have to pay. And a serious disruption. If CERN came out and said, guys, white flag, we're not finding anything new.
Yeah.
There are 10,000 PhD physicists
Without jobs.
Without a job.
Yeah.
So it's horrible. But it's something that has to happen or we're going to continue, we're going another 50 years without finding anything of substance.
And the best comparison is to kind of the church when it started to get phased out. And they looked at these people as having this divine knowledge. Their entire self-worth is wrapped around their kind of thinking that they have this divine knowledge.
The last paradigm change before Einsteinian was the 1650, when they made an observation that the Earth was not the center of the universe. And it took 200 years. Every scientist back then learned in grade school that the Earth is the center of the universe because it's in the Bible.
Yeah.
It's the same thing's happening today.
Yeah.
These guys learn stuff in school that's not true, and they can't wrap their heads around it not being true.
Yeah.
They've been indoctrinated.
Yeah.
It's no different.
And there are, of course, so many scientists there's a spectrum, right, of how much they question what they've been taught. And there's some great scientists that I would love for you to be able to sit down with. And hopefully we can use this platform to set up conversations and discussions like this with those people. But I think for me, what is really exciting about this project, I love your theory and I'm starting to understand it more and more. And I think there's a lot of merit to it. But the goal really is to inspire young physicists to start thinking outside of the box, right? And instead of just, instead of looking for these incremental theories, these incremental growth theories on top of what we currently have, looking for something that could completely cause a new paradigm. And that's exciting because when a paradigm shift like that happens, like when you go from Copernicus's model to Newton's, it leads to this slew of innovation in all these different sectors. Yeah.
It's the most exciting time ever. Yeah, I think what we're trying to do, maybe just a slight change on what you said, is that if nothing else, we'd like to enable these young physicists to challenge their professors. And if some professor says, hey, this is factual, a young kid should be able to stand up and say, no, that's not factual. That's theory.
Yeah.
Because they're teaching these kids stuff that's just flat out wrong, and that's got to stop. And then let the kids be creative.
Yeah, and it's such a subtle difference in the way that you teach someone.
Yeah.
Instead of leading with or basically implying that what you're teaching is fact, and it comes from these people that are really smart and know everything. You just have to lead with, listen, this is our best theory right now.
Yeah.
There's some things that contradict it. There's some things that don't add up.
Yeah.
But just being upfront about that, so people can continue to have an open mind.
And tell the kids what's wrong.
Yeah.
This is where it fails.
Yeah.
And let the kids put that into their thought experiment and try to figure out where it goes from there. Yeah, there's a teeny weeny line between education and indoctrination. Education's wonderful. You can jump off the shoulders of your forefathers. Unless you teach them something that's wrong. Then they're indoctrinated.
Yeah.
And then they're crippled for life as far as problem solving in that domain.
Yeah.
And we've been that way for 6 generations now. And you'd think they'd stop.
It's
Right.
too big.
Yeah.
There's too much inertia.
Yeah, there's too much inertia.
So what are some of those, what are some ideas you have for potential innovations that could come that would have practical applications in this world if your theory has some merit and is adopted?
I think the solution to unlimited clean energy lies in the ability to harvest clear energy, an energy source we're not even looking for today because it doesn't fit the paradigm. I also think there's some amazing things we can do on the biology end for extending human life. If you recognize the interaction of that energy with hydrogen and with subcellular energy production. And those are little ones. There's unlimited space travel. There's a whole bunch of things. And getting there is not going to be easy. And I'm not anywhere near capable of doing it. But I think if young people, really bright young people are allowed to look for it, instead of wasting their time on particle physics, hell, they might find something.
Yeah. I think one of the big issues is that particle physics has led to so many wonderful innovations, right? Like quantum mechanics has...
That's different than particle physics.
Yes. But what I'm getting at here is there's a difference between a predictive model and having true understanding of something. And the perfect, most obvious example of that is Copernicus. He came out with his model of how the planets orbit, and in the moment it's like, this is amazing. We can now predict where every planet is at any given time, because it's got the Earth at the center of the solar system, and then these crazy circular loops of all the different planets.
Yep.
And it requires this complex math to do it.
They brought the mathematicians in to fix the problem.
Yeah.
Brilliant mathematical work.
And I like to think if you were around then, when Copernicus released that model, you'd have looked at that and you would have said, this is amazing. We can tell where the planets are, but this probably isn't what's actually happening.
I'd say that's the dumbest thing I've ever seen. You got a planet reversing orbits?
Yes.
No, I'd say, no, I would have been burned at the stake.
It doesn't pass that sniff test.
Actually, I wouldn't have opened my mouth. Yeah, no, it's the same thing now. The logic is gone.
Yeah.
Logic is gone. Protecting the status quo, conformity is, and math is in. And so, there's nothing's going to change. It's not a self-correcting system. Mm-hmm. It's messed up from the top all the way down. It has been since 1927.
Yeah. So with the Copernicus model, that was around for a long time. And then Newton came along, he put the sun at the center, and then all the planets are orbiting around it, and it's like, okay, like obviously this is right. Like this is simple, it clicks, it just makes sense. But it took an insane leap in this crazy outside of the box thinking to get from where Copernicus was. The people who were just doing more and more complex calculus weren't getting anywhere near finding out that the Earth is in the middle, or the sun is in the middle of the solar system.
I hate to do this to you. You're absolutely right. But Copernicus was the one who put the sun in the middle. It was Tycho Brahe, who was the one on the church side who did all the funny math work.
Oof, yikes. We're gonna have to refilm this entire thing.
No, you don't.
That shows how much I actually know about this.
No, but you know the story. And that is the story.
Wait, so to clarify, Copernicus put the sun in the middle.
Yes.
And the person before was who?
Was Tycho Brahe.
Tycho Brahe, okay, got it.
And he was on the church's side.
Okay, got it.
And Galileo was the one that suffered for it. It was Galileo's observation. Mm. We have a great video of this. It was taken in the Vatican with the head of the science department of the Vatican, who sits there and he goes, "We did not kill Galileo. We killed other people, but we did not kill Galileo." It's classic.
That's actually too good.
But it's a group of guys with a lot more smarts than...
Yeah. God, you'd think I would do the research and figure out
perfect.
who thought it.
Your analogy is perfect.
But anyways, the point I'm trying to make is it's going to take a similar jump to get from quantum mechanics to wherever it is that we're going to go.
And do you know how disruptive that jump was? The Earth is not the center of the universe.
People were killed over it.
Killed over it, and then the church was crushed.
And the church
so the Bible's not right?
Yeah.
The foundation for all Christianity is wrong? So that was really tough.
Yeah. So do you think that if you're able to gain some traction with this theory and start having these conversations with different people, that you're going to see a similar style of hate and get attacked in that way? Just for suggesting that they're as far off as
No, they aren't allowed to burn people now. They can't burn me.
Yeah. Well, the internet is a tough place, though.
No, you know something? The only weapon they have is excommunications. They can take a PhD physicist who's got a wonderful tenured career, and the guy could be out of a job.
Yeah.
I have nothing to lose.
Yeah.
They can't attack me. I don't care.
They're going to write a bunch of like Instagram comments calling you stupid. And
they're really, really hard to argue with.
Yeah, they are.
I mean, these guys they're brilliant, but they're completely misguided, and I think, and they've been indoctrinated into something that they know deep down is wrong, but they're scared to death to have it change.
Yeah.
And I feel sorry for them.
Yeah. Do you think the internet is going to kind of get behind this movement that you're starting?
I hope so. And I hope that the target market is young people.
Yeah.
Particularly young people who have a desire to go into to study physics. The only way to change these guys is to challenge them. Mm-hmm. And to stop letting them say, "Hey, we got a PhD, we know everything, you just got to believe us." You know, credible people have to be able to say, no, 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 no. That doesn't make any sense. That's not logical.
Yeah.
I mean, at some point, logic has to prevail.
Yeah.
And they've completely lost track of that.
Agreed.
The stuff they're coming up with is so dark matter.
We should actually spend some time and just walk through dark matter, start to finish. Maybe I can do a quick, my rendition of
Sure.
what I've heard from you.
Great.
Which is basically that Einstein's theory of general relativity was working great. Everything was fantastic. There was nothing that conflicted with it. And then they pulled up in a telescope a distant galaxy that was orbiting faster than it should, according to Einstein's theories.
Yes. Roughly all right?
Roughly right. More correct than the last one.
Yes.
I've got the names right,
Yeah,
at
you
least.
got
this
Einstein
time.
right, yeah.
Einstein right. And instead of going back and saying, okay, there's something wrong with Einstein's theory of general relativity, let's reevaluate that. They said, by default logic, Einstein must be right.
Yeah.
So there must be this other mass that's surrounding these galaxies that's completely undetectable, invisible in every single way. Send it to the mathematicians, and all of a sudden that takes up 75% of the known universe.
Roughly, yeah.
Yeah.
Yeah, that, and then everybody goes, that is such a bunch of hogwash. And then 30 years later, it goes into the textbooks the kids learn at school, and all of a sudden it's mainstream physics.
Was it
Which they-
hogwash in the beginning, or did people?
people thought it was ridiculous.
People thought it was ridiculous. Yeah.
Yeah. And it was the gravitational theory failed.
Yeah.
Don't believe your lying eyes.
Yeah.
There's dark matter out there. And then dark matter caused a problem because Einstein's theory of relativity would predict that the entire universe would collapse into a pea-sized object if there's that much more mass. Dark energy.
Dark energy. Boom.
The ugly cousin of dark matter. They put those two things in there. And we're not paying attention.
Yeah.
We got lives to live.
Yeah.
And all of a sudden our kids are being taught this stuff's real.
Yeah.
And that's how you perpetuate a hoax. And it's time to call bullshit on these guys. And they're brilliant and they're great guys. I've met a bunch of them. But the fact of the matter is, appeasing them does nothing for the human condition.
Yeah.
We need to move on.
Yeah.
So
And
bite
you're-
the bullet.
Yeah, bite the bullet. I think that's well said. In your moving Chasing Einstein, which is incredible, plug Chasing Einstein. One of the main characters is searching for dark matter. Like, she's created a dark matter detector, and she's dedicated. And you knew her personally, and she was a friend. Or did you meet her
I
personally?
met her through the movie.
You met her through the movie, yeah.
Wonderful woman.
Yeah, and she created this team of people, and they devised this brilliant, scientific experiment where they buried something deep beneath a mountain, and they collected all this data, and then they released it from the black box, and they unfortunately weren't able to discover anything.
Goose egg.
Yeah,
Yeah, they're not going to discover anything, but I'll guarantee you they're going to announce something.
yeah,
We saw something.
yeah. I mean, there's a Wall Street Journal article every 5 months that's proclaiming that there's some crazy discovery, and then you dig into it a little bit. And
So these guys, one of the requirements of their jobs, for better or for worse, it's created a whole bunch of fraud in the industry, is in order to get ahead, you have to publish. And these guys are willing to stretch the rules to publish something because their careers depend on
Yeah.
it. And I don't blame them.
yeah,
But it ends up with a perverse incentive to guys that are supposed to be following true science. And we suffer for it.
yeah. And then there's the peer review, and I'm not intimately involved in the workings of this, but you'd think when you get to a certain level and there's all these people in this echelon, I'll peer review yours if you peer review mine.
Oh, yeah.
Like, there's this process of
Oh,
they're
yeah.
all scratching each other's backs.
And this guy writes a paper and he goes, I'll let you put your name on my paper if I can put my
Yeah.
name on your paper.
Yeah. And then
'Cause
an
the more-
outsider comes in with a piece of paper like this, and they say,
No, there are outsiders that come in and pay people to put their names on it. There's a couple podcasts about this, but it's not their fault. Their incentives are completely unrealistic.
yeah,
And again, they've got lives to live. They've got families, and I blame the industry.
yeah,
It's just wrong. They've got this peer review processes. No complex problem has ever been solved by committee. These guys will never solve it. Committees are structured to protect the status quo.
yeah,
And that's what they're doing. And as long as they're in control of the truth, they decide what's the truth, and they're going to crap all over this stuff.
yeah.
And I'll tell you, I'll handle myself with any of them. They're gonna pull up all this math and all these formulas and all these ideas, and the entire thing is based on a platform that's rotten at the core.
Yeah.
And you can't expect the stuff that's built on that to be solid. It's not, and they know it. And it's just it's a bitter pill to swallow.
Yeah, it's going to be really interesting. There's so much skepticism for institutions in general right now.
This one rivals the U.S. government. Very close. The nice thing about these
in
guys,
what?
though,
How does it
for
rival?
them is it's sort of amorphous. You don't know who the peers are.
Yeah. Yeah.
There's nobody to go attack and say, hey, what do you mean? That's the dumbest thing I've ever heard. This is a collective group of all of the gurus in the industry.
Yeah. And they give each other the medals and they wear the robes and yeah.
I mean, so many of the things that have gotten Nobel Prizes are just, if this is successful, if this works and it gets legs of its own, it's going to take a while. They should be rescinding Nobel Prizes. Keep the money, but give us the medal back.
You think so?
Some of the stuff, it's just based on, and again, it's not their fault. And the Nobel Committee has got to give a prize out every year.
Yeah.
And it's hard to find something to give a prize to.
Yeah. Yeah.
They have the same
I hope they
challenge.
get to keep them though. The Reggie, I hope they get to keep
It's
them.
not the Reggie Bush Heisman Trophy thing, yeah.
So what is actually happening at the center of an atom?
Well, let me tell you what's missing. And Einstein told us this in 1920, but the peers dismissed him because it was too disruptive. He said you have to add back in an ether, and ether is physical properties of empty space.
Yeah.
And this theory that has been developed is one that said you cannot use fundamental force cop-out. You can't say things just happen because they happen. And the second is it's got to scale from the atom to the galaxy, because galaxies are nothing more than a whole bunch of atoms. And if you do that, you got to find an energy source for the atom. So you add back in an ether that has energy properties that is attracted to matter, and the whole thing scales so easily.
Yeah.
Logically.
Yeah.
Mathematically.
Yeah.
And it's just one change. And Einstein was the first one to call the change out.
Can I give you how would you explain it to a fifth grader answer?
I would like to hear it.
And you can critique it?
I'd like to be able to say it.
Okay. So my oversimplification is the entire world is floating in this ether. What we see as matter.
But sir, what's ether? It's hard.
It's hard. And my explanation for ether, I guess, is ether is the property that's in empty space. Ether is here, it's there, it's everywhere. It's basically the fourth dimension.
It's universal.
Right, it's universal. It's where consciousness could potentially live after death.
Is this still the fifth grader you're talking to? You have just went right to a PhD student.
When your dog went to the farm, they actually went to the fourth dimension. Sorry.
That's right. The dog's in a retirement farm someplace in the Middle East.
So basically, like what matter is and how an atom works is it's this node similar to a flame of a candle. The way a flame of a candle works is it's sucking in oxygen from every different side and it's turning it into a flame. What an atom is doing is sucking in this ether from every different angle and it's turning it into this plasma field that we perceive as matter. And when you get every single atom has the same requirement. And so when you bunch them together and you create a massive ball of them that becomes the size of a planet or a sun, it starts attracting more and more ether. And it creates this flow like a pressure system within the galaxy where the ether is flowing towards where it's being attracted to. And the drag of ether onto particles is what causes gravity. And it sucks matter into the center of these planets or suns. And then the follow-up question that Steve had was, or actually you want to correct anything I have so far?
No, but you blew by the fifth grader a long time ago, but that's correct.
Eighth grader, maybe?
No, God, no.
Ninth grade? I don't know how smart kids are anymore.
I'll tell you, it's just the problem with this thing is words.
Yeah.
But obscure words.
Yeah. And then I think one thing that resonates with people when I explain this to my friends and whatnot is clear energy is turning into matter at the heart of planets and suns. What's happening in a black hole is that's where a pressure system is created and those suns are being converted back into clear energy. And then that's being shot up into into empty space, and then the cycle repeats itself.
You just broached a subject that I've never even talked about.
So an atom is taking clear energy, and it's turning it into matter. What happens is when an atom hits a black hole, it's converted back into clear energy.
Yeah.
Yeah.
So there's a life cycle of energy.
Yeah.
And there are 4 states of energy. There's matter, equals mc squared. There's plasma, which is a transition energy, and there's radiated energy, then there's clear energy. And there's a life cycle, and it's a continuous life cycle. It goes from clear to plasma to matter, back to clear. And the black hole provides the same function for Mother Nature as a hurricane does. It restores balance in a region of space. Hurricane does it for atmospheric pressure. A black hole would do it for the balance of energy in different states in a region of the universe.
Yeah.
It's really simple. So black hole in our definition is exactly the reverse of Stephen Hawking's black hole,
Which is?
which is the most dense thing in the world, and it draws in entire universes of stuff.
But it's undetectable. Can't see it.
It's undetectable because it sucks it all. So it's simply just to tie the whole thing together. This is the energy dimension. We are all energy. Consciousness is energy. There's nothing here but energy, and it has different representations.
Yeah.
But it's the energy universe, and there's a life cycle of it, and it's continuous.
What's the closest you've gotten to having a conversation like this with a physicist who's considered testing and doing some math to see if the stuff that you're talking to checks out?
Never. There's no math. All the math they have is right.
Yeah. Well,
it's the same.
So the math for a black hole, for example,
Yeah.
what you're saying is causing the orbits around the black hole isn't actually the same as gravity.
Yeah,
It's
that's
caused by a pressure system.
Yes.
How would that be calculated?
Well, they can't calculate black hole waves except using Einstein's theory of gravity.
I guess I'm talking about how can your theory account for the orbits that don't make sense under Einstein's theory from a mathematical standpoint?
The speed of the rotations is directly related to the energy balance from a clear state to a different state.
Yeah.
And if the energy balance goes far too much into matter, into plasma, into radiant energy, the rate of orbit will be faster. There's no relationship between the mass of the central object and the mass of the orbiting stars. As there's no relationship between the speed and the mass of the rain cloud at the edge of a hurricane and the speed and the mass of the rain clouds in the eye of the hurricane or near it. They're completely. It's an entire system. It's not a attractive force at a distance. That's just it's just mind-boggling.
Yeah, and that logically, like, I don't know about for the people here watching, but that makes a lot of sense to me. Hurricane, things are spinning faster as they come to the beginning. It works different from gravity, so this theory could check out. How do we get a scientist who's really good at math, who understands black holes, to say, okay, if we look at this not as gravitational pull, but if we look at this as two pressure systems colliding, can we make the math check out? How does that process need to happen?
They've got the math for the black hole, but their interpretation of the math is using Einstein's theory of gravity.
Yeah.
So when the math doesn't work, there's not enough mass in the black hole, they have to create more mass.
Yeah.
So all they do is add mass to it, and the math all works.
Yeah.
Okay. Ours can have, we don't need the mass of the black hole, because the mass of the black hole is zippo.
Yeah.
It's none. It's
Yeah.
the eye of a hurricane.
Yeah.
So the math that they have is really good, like the rotational speeds of stars. The description of actually what it causes it is completely off.
Yeah. Yeah.
So what's great is that the new theory is completely consistent with all of the math that they've come up with.
Yeah.
It doesn't defy the math.
What
It
makes
simply
you sure
describes.
that your theory for how the black hole is attracting these objects is in line with the math there?
We have the only observations we have of the movement of galaxies is the Andromeda Galaxy and the Milky Way Galaxy.
Yeah.
We can calculate speed of rotation. And the speed of rotation will vary depending on the energy balance in that region of space.
Yeah.
There is, outside of the reason why Einstein's theory needed to be clarified, because it's completely dependent on the mass of the black hole to justify the rotational speed of the stars.
Got it.
Mine is not.
Got it.
Those are completely independent things.
Got it.
They're connected through the currents of ether,
Got it.
but they're not related in any way, except that a star is going to fall in the black hole. It's gonna destabilize, and you're gonna end up with giant quasars of plasma energy coming out both sides.
Yeah.
That will ultimately recycle back into the body of the galaxy.
I think my fundamental understanding of what dark matter has been off this whole. Is all dark matter at the center of a
No,
black hole?
it's
distributed.
They've distributed it.
Yeah, through the most complex.
It's everywhere.
It's everywhere.
It's everywhere. It's matter that's everywhere that cannot be detected.
Yeah. Yeah.
How
So
do you teach that to a kid?
yeah,
How do you say with a straight face?
it is crazy. And I think like one of the main reasons that we've got this whole production studio set up and the lights and we're having these conversations and putting them on the internet is because we want to find people, young, bright minds who have good understanding of black holes and kind of the math to come into this conversation with an open mind and have a conversation and try to. So if you're watching this and that's what you do, comment on our videos or something.
And I want to absolutely encourage you to not blindly follow their lead,
Yeah.
because they've wasted their entire lives on a theory that just doesn't even work. And
Yeah.
don't fall for the same thing.
Yeah. The odds of this one being right are pretty small to me. I believe in you, Dad, and I think this is amazing, but this is going to lead to what is right, whether it's you or someone else. It's going to lead to a paradigm shift. I really believe that.
Yeah, I think it's right. I don't care. I don't care personally if it's right.
Yeah.
But I know that what we have right now is wrong.
Yeah.
And if there's not a disruption, it'll continue indefinitely.
Yeah.
And I'd like to see unlimited clean energy in my lifetime. I'd love to see an extension of life. And these guys won't discover anything new to lead to that.
I tried to do the 5th grade explanation. What grade are you going to give me?
I'm going to take junior in high school.
You're going to do junior in high school? You give me a grade on my 5th grade explanation? Is it like a B, a C?
I think it was
or?
great if their 5th graders were 18 years old.
Oh, I see.
Perfect.
Okay.
Yeah, so the theory is really simple. We make one change to the physical construct of the universe, and we add back an ether, which is what Einstein told us to do, and define it as having energy properties and interacting with matter. All matter needs energy. It sucks in ether. So the rest of the model can be built really simply on things I call energy systems. An energy system is where there is a element that drives the movement of clear energy in that region of space. The smallest energy system in the universe is the atom. Mm-hmm. Everything's built on that energy system. So as the energy approaches the atom, it condenses and takes a plasma state and then makes electrons. So the atom is sucking in energy. If you put a bunch of atoms together, you get things like the Earth. The Earth now is the energy system for this region of the solar system. It's got a much larger energy system. And all of the energy in that energy system is directed by the energy needs of the Earth. Mm-hmm. You got a whole bunch of matter, you get something as large as the sun, you got a much bigger energy system. The Earth is a compounded energy system in the sun's energy system. The sun is a compounded energy system in the galactic energy system. All of it behaves exactly the same. All the motion is driven by the movement of clear energy toward matter.
Okay.
And all motion is objects riding on the current of that energy.
Okay. That's good. I'll give you B+.
You're going to be critical, are you?
That's very good.
I'll work on it.
I think one way to approach it, or sorry, you finish your thought.
No. I say with it needs graphics. You need visuals.
I think one way to approach it is most people are probably familiar with the 4, what are they, fundamental laws of physics. Fundamental forces, excuse me. And the 4 fundamental forces are basically 4 random, disjointed assumptions that need to be made to hold all current theories together.
Yeah.
The first one of those is gravity.
Yep.
In the current theory, there's no explanation for how gravity actually works. So where your theory comes in, it explains gravity. How?
It's like they think they can explain it by the bending of space-time, which is a bunch of crap.
Okay.
Mine is as energy approaches a big dog, the Earth, it gets greater and greater concentration because the volume it occupies is reduced as it gets close.
Yeah.
And the gravity is the drag of that energy moving toward the body of the Earth as it passes through us. And don't forget, we are 99.9999% plasma fields. Mm-hmm. We are not solid. We're solid objects from our perspective, but we're not solid. As it moves through us, it drags us toward the Earth. It's not a magical, attractive force. It's a current of energy passing through other physical structures.
Okay. And then the strong force is another fundamental force. What do they say that is, and how does your theory discount that?
So in 1932, they started shooting protons through an electromagnetic ring. And some of the protons veered one way toward the ring, they had a positive charge, and the other ones went straight through. They had a neutral charge. They assumed, because there was no energy needed for the atom, they assumed that there were two things, protons and neutrons. Protons should repel each other, but there are multiple protons in every atom except for hydrogen. And they couldn't explain how they could hold together in the tiny little nucleus. And so they invented the strong force. How does it work? It just works.
So basically, they saw that in the nucleus of an atom, there's a positively charged proton.
And a neutral.
And there's a neutron. And they should theoretically go,
The positively charged one should shoot apart from each other.
but it doesn't.
It doesn't.
Instead of trying to think of an explanation for why that's happening, they said, let's just create the strong force.
Yeah.
The strong force pulls them together. Yeah.
Where'd it come from? Well, 0.0000 seconds after the Big Bang, the strong force was there.
Is that actually true? They just said Big Bang and then the strong force
I think
popped
it's
out
10
of
to the
nowhere.
minus 43rd seconds or something.
Yeah, see, that's pretty wild. And your theory accounts for why the proton and neutron stick together.
So in my theory, the energy is being harvested out of the field that it's created.
Yeah.
It comes in, and there's a current that runs through the nuclei. It's an internuclear current. And that current, each nucleon, each proton and neutron are shifting charges thousands of times a second. It's like a current, electric current. So a proton is a neutron, and a nanosecond later, the reverse.
Yeah.
And that's the current running through. It's just like an electric lock.
Yeah.
There's a current that's holding those things together.
But it's with an electric lock, as soon as the current goes away, it fails.
They separate.
Yeah.
Yep.
And so basically, there needs to be some power source that is running the electric circuit between
It has
the
to
two.
have a continuous power source.
Yeah. And that power source is coming from clear energy. It's coming like this.
They create what's called a fundamental force, which just happens because it happens, and then nobody asks questions about it anymore.
Yeah.
It just happens because it happens.
Yeah.
And it's just shocking to me that people accept that. That's one of the things I think that should disqualify the standard model of physics is you can't use fundamental forces. You got to explain what's happening.
And that's why these scientists are saying things like the current standard model is a warm-up act for the theory that's yet to come. But there's so little effort going into looking for the new revolutionary theory. The third I have very little understanding of. That would be the weak force.
Weak force is trying to describe what is ejected from atoms under certain conditions, photons. It's really not that important.
Okay.
The important one is electromagnetism.
Okay. Let's skip to that then.
So electromagnetism is every atom in the universe generates an electromagnetic field. Magnets all have the atoms lined correct in the same direction. They stick to things and things stick to them, incredibly powerful because all the fields are aligned and they work together. They're very powerful fields that come out of every atom in the universe. Those fields are a byproduct of the current that runs through the nucleus. We can test this in our laboratories. We can run a current through a wire, and the wire will there'll be an electromagnetic, there'll be disturbance in the medium around it. Same thing with the electromagnetism. What's really interesting about magnets is almost every bit of energy we have produced, electric energy we've produced, comes from harvesting the energy off of electromagnetic fields.
But it's not hard. In that case, when it comes to generating energy, what the magnet is doing is just transferring physical kinetic force into electricity, which is a different type of force. It's not actually creating energy, it's transferring, right?
It's creating physical energy. The energy is not physical. So the way a transformer works, or a turbine works, is you've got a ring of magnets around it. And inside of it, you have a conductive coil, copper usually. When they say, hey, that's nuclear power or that's wind power, wind isn't making any energy, there's hydropower. None of that's being made by hydro or wind.
It's just a spinning.
It spins a crank.
Yeah.
So when when the conductive material spins inside of these fields, it generates electricity. So it's taking energy from a non-physical state, the electromagnetic state.
The physical state to me is that spinning rod, because that rod spinning has a lot of kinetic force.
You need to spin the rod in order to harvest the energy off the.
Yeah.
But you can take that rod and you can spin it as fast as you want to, as much nuclear power as you want. You take away the magnets and nothing happens.
Yeah.
You have no electricity.
Yeah. Well, you can connect the spinning rod to a sewing machine, and then the sewing machine starts running. You know what I mean? Like
you can transfer whatever energy you use to spin something into kinetic. I can convert my muscle energy into kinetic energy by pumping it up. Yeah, that's true. But I think the key to this is, though, we have turbines out there that have been hydro plants for 120 years. They've created the equivalent of billions of pounds of electrons, which is, it's not right, but that's currently how they measure stuff. Billions. And these magnets are exactly the same size, exactly the same weight, with exactly the same electromagnetic strength. Nothing wears out. Where does the energy come from that lets those magnets create those fields forever that are so powerful? It needs an energy source. Physicists today say, well, that's a fundamental force.
Really?
Yeah, don't worry about it.
When was that created? I have a wild guess.
A fundamental force?
The electromagnetic fundamental force, I think, was probably created right after the Big Bang.
Yeah.
Is that right?
No, I think it was 10 1 billionths of a second after the strong force was created.
Oh, after the strong force, you think?
Who knows? What's really funny about the Big Bang timeline is it is the island of misfit theories.
Yeah.
If you got something that makes no sense, all you got to do to show that it exists is to put it on the timeline.
Yeah.
Plug it in on the timeline. Well, this was 3 seconds after the universe was formed.
Yep.
Gluons came into effect. Whatever you want.
Yeah.
And then you go, okay, move on.
I saw one article that said that the fundamental forces, or the standard model, is the equivalent of taking a platypus, a dolphin, an elephant, and a rat, and taping them all together, and then calling it science's most elegant creation. It's just like, what is this?
It's about like that.
Yeah.
And don't believe your eyes, believe us, because we're going to tell you this is the perfect animal.
Yeah.
No, it's if you take it apart piece by piece, it's ridiculous.
Yeah.
So if we can get them to defend what they have, not to tell us what they have, say that doesn't make sense. Explaining how that works.
Yeah.
I've done this with a physicist. I said, how do you explain a fundamental force?
And it probably says, listen, man, it's either this or you got to go back to square one.
They don't ever get that option.
But they would never say, like, it's either this or
the answer I got for where do the fundamental forces come from is the hand of God. We'll never know.
God, yeah.
It's beyond us. It's beyond our. No, it's not beyond you. It's beyond your stupid theories.
Yeah. The hand of God created 4 fundamental forces.
No,
strong, the weak, and the.
He created the universe in 7 days, 6 days, and took the 7th day off.
Took the 7th day off. That's funny.
No,
Okay,
they don't address the problems. The other problem they have is everybody's in a little silo. I'm going to fix this problem inside of particle physics at CERN laboratories or Xenon labs or someplace else. This isn't a little tweak.
Yeah.
The only way this thing can be this screwed up, and the theories for the small stuff can be mathematically irreconcilable from the theories of the big stuff, is there something at the very beginning was rotten.
Yeah.
That's the only way. And talking to these guys about it, there's no other option.
Yeah.
You can't screw up this far and expect it to be pulled back together.
Yeah. It'd be interesting to spend some time talking about the discoveries that have actually come from quantum mechanics and quantum computing.
Let me take this over. Quantum is brilliant.
Yeah.
Quantum is not a theory. Quantum is a probabilities mathematical tool.
Yeah.
It has invaluable in technology. When how much energy can I pass through this transistor, get to the other side? What's the probability that it reaches the end? When they start shrinking stuff, quantum is fabulous, but it's not a theory.
Yeah.
And we can't conflate success in technology with success as a theoretical principle. Not related.
And that comes back to Copernicus and that other guy.
Tycho Brahe?
Tycho Brahe, which we've talked about.
That history, infamous in history.
Yeah. You can have a really great predictive model, that does an amazing job and allows you to look into the future and sense probabilities, but that doesn't give you true understanding. Yeah.
Getting back to the dark matter thing, it screwed everything up, the observation. And then they figured out how to fix it so the math would work. Celebrations.
Yeah.
Hey, the math
Put
works.
on the robes. Get
The
out
math
the
works.
medals.
Nobody's going to believe that there's all this matter out there. Who's going to believe that?
Yeah.
Don't worry about it. Leave it for a while. And here we are. Yeah, it's in our textbooks now.
It's crazy. It's crazy.
How dumb are we?
So the difference between the corrected model and the current standard model is essentially that the 4 fundamental forces that were inserted to explain observations that were made that they otherwise couldn't explain can be replaced by this simple concept that there is an ether out there, that there's property to empty space, and that the power of an atom is sucking in that ether from empty space into its nucleus, turning it into a plasma field, and that is what we see as matter.
Yes.
So when you stack a bunch of atoms together, they need to suck energy from further and further away. And that, at scale, is what we then perceive as gravity.
Yes. Yeah. And the problem with both quantum and relativity is they're both based on a faulty series of assumptions. They both started flawed, and nobody replaced them, and they continue to get more and more bizarre over time. The corrected theory is far more simple and far more complete than what has been given to us by our current theoretical platforms. And I think that if we can, again, get enough young people talking about this stuff and demanding, not just blindly believing people, but demanding some type of explanation, and the physics community goes on defense, the house of cards will fall. And then we get to rebuild it. And that's when the really fun stuff happens.
Well, Dad, thanks for sitting down. This has been a great conversation. If you've been watching this, we appreciate your time. We appreciate your attention. As mentioned, the goal of this is to spark interest from the youth and not just adding on to the current theories that we have, but looking for entirely new theories and entirely new ways of looking at physics. We've got a ton of other material on our website. We're called Beyond Einstein. You can find us on Instagram, TikTok, everywhere you find stuff. And hopefully there will be a lot more long-form videos like this to come. And I also want to say, the whole point of this is to create dialogue. So please, comment on this video wherever you're seeing it. Go to our website and let's start a conversation.